Yeah. So good afternoon, welcome everyone to the first webinar of this series, proudly presented to you by the Green Building Council of Mauritius. This week we are celebrating sustainability, and with it the World Green Building Council's drive called #BeBoldOnBuildings. My name is Clare Smith and I'll be hosting today's webinar together with our guest speaker, Mrs. Fátima Martín. Just going to share my screen with you. Okay. So before I explain to everyone what we're going to be presenting today, I just want to say a few words about the World Green Building Council. The World Green Building Council catalyzes the uptake of sustainable built environments for everyone, everywhere, transforming the building and construction centers. Sorry, I see some people, I'm just going to admit them. Across 3 strategic areas: climate action, health and well-being, resources and circularity. These are the global action network of over 70 green building councils around the world. The Green Building Council Mauritius is a member of the World Green Building Council and is part of a rapidly growing African network of green building councils. GBCM is uniting the Mauritius building industry using sustainability as a catalyst to positively transform places people work, live, play, and learn. It's a not-for-profit organization committed to transforming and leading the built environment sector in Mauritius towards a sustainable future. Our mission is to promote a sustainable approach to planning, design, construction, and utilization of the built environment. Right, so on to our presentation. We at Green Building Council Mauritius wanted to open the discussions around sustainable building techniques and materials. So we therefore started this webinar to explore possible alternative yet sustainable construction methods suited specifically to the Mauritian context. Mauritius, being an island country, it's imperative that we look for new and alternative ways to minimize the environmental impact of buildings throughout the entire life cycle, from material sourcing right through to demolition and recycling. So I would now like to introduce our first guest speaker of this webinar series, Ms. Fátima Martín. Ms. Fátima Martín is a bamboo specialized architect and builder. She was born in Madrid, and after graduating with honors in the Polytechnic School, she obtained scholarships to learn bamboo techniques in Colombia and India. In 2009, she started working as a design architect, construction manager, and trainer for different agencies of the government in India, where she has been based since 2017. As freelance, she's also worked for the private sector, NGOs, other institutions, such as Cervantes Institute, the Spanish Embassy, and UNESCO supported agencies, combining the construction of permanent living spaces with temporary structures for festivals and events. She has given lectures and workshops on bamboo and sugarcane construction for different institutions in Austria, Spain, Portugal, and Mauritius, and collaborated in several studies of bamboo resistance. In 2020, she moved to Mauritius, working as a master teacher at the ENSA School and consultant architect. Since then, she's focused on adapting her designs and developed specific construction solutions suitable to local bamboo and cyclonic conditions. She has focused as well on the training of a local team and together form Bambulenat, a group specialized on consulting services, design and implementing of bamboo construction. So with that, I hand over to Fátima, and just for everyone to take note, the presentation will be around 45 minutes, and then afterwards we'll open the floor to all the attendees who have any questions and share experiences, or if they have any comments.
Fantastic. Thank you very much, Claire. Can you all see my screen correctly? Claire, sorry, can you see the screen correctly? Perfect, great. So thank you very much for coming. It is very difficult for me to speak about bamboo for only 45 minutes. If you give me 3 days, it will be much easier. So basically, I'm going to just give you some very, we are going to go in a very brief journey through some general concepts, some construction ideas, and then specifically, I want to focus on my experience in Mauritius. Sorry. As you may know, we basically find bamboo in places where we have water, either on the sides of rivers, but actually we also find it in many rainforests. And the best bamboo to construct is the one we find actually on the hills above 1,000 meters. In Mauritian context, we are having basically 3-4 species of bamboos, and in the plains is where we are finding for the most suitable bamboo for construction, even it's a very small size. Bamboo is distributed all over the tropical and subtropical belt. So when we are thinking about bamboo, maybe we are thinking about 1-2 plants, but actually it's a family that consists on more than 1,500 species, out of which around 300 we can call giant bamboo. So giant bamboo will be basically bamboos that have poles of around 10 centimeters. So a very brief view on environmental benefits. Bamboo is a champion on this. Bamboo has a very high percentage of fixation of CO2. No tree can compete to it, and biomass production. So it has many applications actually for production of energy. Bamboo is also a great agent to regenerate damaged soils and eroded soils. So it will, as it's a plant that grows so quickly, as we are going to see, it produces very quickly a shade, and it will enrich the soil with its leaves, but it also becomes a wind protection for other plants to grow. We provide this protection. Will also produce all this biomass organic matter, and will also, with the reticulated roots, prevent erosion of soil. It also has great properties for water cleaning and restoration of riversides. The bamboo will oxygenate the water, and unlike it is thought, some people say, I don't plant bamboo because it will absorb all the water of the ground and will dry other plants. Well, that's a big lie, because what happens is, like, bamboo has an amazing capacity to store water inside of it. So the concept is more as if you are enlarging the water capacity retention of a soil when you plant bamboo. When we are looking at a bamboo plant, maybe we have a very big confusion. Bamboo is not a tree. Bamboo is a giant grass. So when we are looking at a picture like here on the right, we may think we are looking at independent plants, independent trees. Not at all. This is a single plant with interconnected roots, and a bamboo plant can extend for hundreds of meters, actually. So we will find mainly 2 big families of bamboos. We have what is called the sympodial bamboo, which is this bamboo that which has a linear running root, and this root will, from this root, several poles will grow in a certain separation from each other. Then we have the bamboo that we find more in the subtropics, the bamboo we find in Mauritius mostly, which is this sympodial bamboo that grows in bundles. And in this case, the roots grow one against each other, the rhizomes, and it results in these bundles. And this sympodial bamboo tends to curve more than the monopodial. I'm saying this because now we are going to see how these characteristics of bamboo will make certain designs more suitable for one kind or another. Getting to know the bamboo a little closer, So imagine we are taking this portion of a bamboo, and I'm bringing you very inside the walls, inside this internal structure. So what we find is that bamboo is composed basically by fibers and connectivity tissue called parenchyma in between them. Well, these fibers are basically the muscles, are the bundles that will push all nutrients, saliva up and down of the bamboo. So what is very important is that bamboo has solely only longitudinal fibers. This is very, very important for its applications. So yes, when we look at a bamboo, this is, as I say, a piece of a wall. For sure, before I need to tell you that bamboo, as you may know, is not a solid material, it's a hollow material composed by different cells. And these cells are separated from each other by internal walls called diaphragms. And this is a little picture of a bamboo wall. So here in this bamboo wall, I want to show you, you can see these small black dots. So these are all the fiber systems. And that is the way you will realize how much bamboo is around your life. Probably 95% of your kitchen, the cutting board or knife or a spoon or whatever, it will be for sure bamboo and not wood. And the way you can identify is by looking at this and finding these dot spots, which are these black spots, which are the fibers. So, well, yeah, I don't want to go into much details, but there is a certain fiber distribution on the bamboo, which is not even. And I just have left some slides here for the record. So if anybody wants to come back in more detail, so these are some principles. So for example, we are finding much more fibers in the outer part of the bamboo than in the inner. When the bamboo grows, basically it will grow its full length with its final diameter very quickly in the first 5 months, 1 year. And then it will slowly increase the thickness of the walls towards inside until it reaches its maturity, which may be after 3 years. And that is why the outer part of the bamboo is the eldest, is the one that receives the sun, produces this lignification, and you get all these fibers. That's why when you go towards inside, when you open a bamboo, the bamboo is very soft inside and very hard outside. So we should never remove the outer part of a bamboo and remain with the inner one. That will be a very big mistake and going against the nature of the bamboo. When we are talking a big difference I want to put here between bamboo and wood is this. In the wood, we will find, apart from longitudinal fibers, we will find the growing rings, and this we can say they are annular fibers, and forming all these circles, as you know, as it grows, and the medulla rays, which are basic radial fibers. So the mechanical behavior of wood, it's very, very different from bamboo. Bamboo can be more associated to metal, even to a metal tube, than wood. So having only longitudinal fibers, this is a very important thing. Bamboo works best at normal stresses, compression and tensile stresses that will go along the fiber. So in the moment we are thinking on torsion, we are thinking on flexion stresses, those are the moments where we have to be extra careful, and where bamboo will not be as competitive as when we are putting it in a situation where it works on compression or tensile. I don't want to talk about the numbers again. I leave this for the record. But mainly, I want to say that bamboo, apart from its environmental benefits, apart from its quick rate of growth, it's an amazing ally for earthquake and cyclone resistant architecture. Due to, first of all, its flexibility. So normally the bamboo, due to this, is able to get very high deformations before it will collapse. Even in case of collapse, due to its lightness, the damage that it creates, it's much less than any other, of course, heavier material. And also, due to its flexibility, we can achieve, in a very easy and natural way, we can achieve these aerodynamic shapes that, as we are going to see, will behave very well against the cyclones and the stresses of the wind. So when we want to think on bamboo as a construction material, first, there is a certain procedure to follow. Again, I don't get into details, but basically, there are certain manners of how to harvest the bamboo. The bamboo needs to be clean, and then we will need to treat the bamboo with certain salts, certain chemicals, not eco-friendly chemicals. For doing so, we first need to perforate these internal walls of the bamboo, the diaphragms. So we will make a longitudinal perforation of the bamboos. And there are different methods. The most common method is what is called the immersion method. So we will have a pool where we will immerse the bamboo for, let's say, around 10 days, 3 weeks. It depends of the concentration of boric acid and borax that we use. So these are the two chemicals that produce a salt altogether, and this will prevent the bamboo from future attacks of insects and funguses. Among other reactions, basically the pH of the bamboo, which is acidic, is quite sweet, will become more alkaline. And as you may know already, funguses and many other microbes will not reproduce on an alkaline media, but only on an acidic one. So we are going to see quite quickly also different approaches to bamboo structures. So here I will start presenting you more tradition in the sense of we are thinking about beams and columns and what we call 2D structures. So this is a construction which happened in India, in Bihar, and it was designed along with the University of Linz, with Sebastian Milanek and Iris Neubauer. And it was a construction in which we combined adobe bricks, as you can see, and then a bamboo structure. So when I say a 2D structure, I mean that we are having columns connected obviously with beams, rafters, purlins, and that as if we were working with any other material, it could be concrete, it could be wood or any other thing. So in India, unlike in Mauritius, we need to calculate for around 100 kilometers per hour, 120. In Mauritius, as you will see later, we need to calculate for 300 kilometers per hour. No? So you are going to see also the difference between these type of structures and the ones that need to be developed in Mauritius. I will pass a little quickly, so we have enough time to go into the details later. So as you can see here, I was also using the bamboo to make the, to make all the veranda. So here we use a split bamboo, and also to do the flooring for the terrace. We can also construct many kind of trusses on bamboo. Here, basically the people are applying the logic of metal constructions into bamboo. So for example, this type of constructions are very much used in Colombia, where they have the bamboo that the monopodial bamboo that grows separately. So the poles that you can find there are much straighter. So these are some of the examples. There are many different trusses that can be designed and produced. This is a very special type of truss. I like very much. They call it the fish truss. because many times when bamboos are curved or are not perfectly straight, they are rejected. So what some people started to come up is with ideas of how to use this rejected bamboo into a very efficient way. And actually what happens is that in the moment we start using this flexibility property of bamboo, curved bamboo, the designs and the details start to simplify more and more and more and more. Curves are very efficient in the way they behave for the stresses. We also can explore a little the world of some 3D structures. We are going to see geodesic domes, and I just directly go for it. Please, if I am speaking too quickly or if something is not clear, please kindly let me know, because I am very conscious of the time that I have. So I am going a little rushing on the points. So yes, as I'm saying, for example, we are finding many examples of geodesic domes. This is very practical to use in bamboo due to, as I say, the lightness of the bamboo. The question here is, of course, what type of joineries and to find the straight bamboos. So you can see that sometimes when the design depends of a bamboo being very straight, then you can directly think on certain species of bamboo. And when you will see now the curved structures, then we can think on the other species that grows in bundles. So we are relating the design to the growth of the bamboo directly, no? So we can also, there are many examples also of these 3D structures, such as high bars. So here, basically, it's a self-portable surface. As you can see, this is constructed in the ground, and then you just lift up all this roof and just make it pose into certain supports, no? This is also a very efficient way of constructing. And again, this ruled surface, they are very friendly with bamboo, because as bamboo allows certain deformations, any small inaccuracies on the measures or this can be taken very easily with bamboo. And also due to its lightness, it's very easy to produce a large surface on the floor and then lift it up with some poles, as you can see in the picture, in very simple means. Another example from Georgetown, it's the Three Mountains project. And here, again, as you can see, we are working on this element I'm going to share now. This is a hyperboloid tower that Georgetown developed very much. And we are working on the idea of these curved tension rods. This is in Bali, and some of the detailing. And now we come to probably my favorite part, which is the shell-like structures. I love to share this picture because one of the places where I really learned bamboo was in the northeast of India. And probably I think they are the highest experts of bamboo in terms of traditional aerodynamic structures. So for them, when I was talking about bamboo shells with them, this idea of the turtle for them was very, very intuitive, because in the Northeast you have elephants, and they say when an elephant steps on top of a turtle, it doesn't break it, no? So this idea of the strength of the shell, it is very intuitive inside of all of us, and especially on those places where the tradition has not been lost, and places such as the northeast of India, where they are exposed to winds, to earthquakes, cyclones, etc. So when we are talking about membrane shell-like structures, we are talking about a huge family, but mainly are structures that will be tied in very different directions. I'm going to show some examples. These are traditional examples. This is the eldest typology of building known. These are the Mudeef houses in Iraq. And they produce with this natural grid. This is not bamboo, But let's say that cane and other fibers, we are all talking about the same big family of Graminea, so they have certain similarities to bamboo. So this is an amazing example, and I say it's the eldest tradition known. We have constructions which are other type of traditional constructions that used split bamboo, such as the Ethiopian traditional houses. As you can see here, it's very much this shell-like structure. We are talking as if a gigantic shell, a gigantic basket. So when we are talking about shell-like structures, we are talking about forces along the fibers, pure compression or pure tensile, when we are talking about the wind stresses of suction. Load and stresses are evenly distributed along the surface. We have multiple joining points, articulated joinery. We are never embedding elements when we are making a shell-like structure. Actually, you can never consider bamboo joinery as embedded joinery, it's always articulations. And then we are always constructing in different layers. We will have some main arches or a main structure which is attached to the foundation. We will have a secondary structure which will be connecting this primary, and we will have a third one. So we will have layers of structures that will result into multiple points and an interconnectedness on the structure itself. It has also the quality of taking aerodynamic shapes. When we go to shell-like structures, again, we start to deep into these aerodynamic shapes. So there is a certain principle of how, when we are designing a building, the response of the building towards a wind, for example, a stress. So I don't want to enter into this, but depending on an aerodynamic shape, what will happen is that against a given force, the response of the building to this force will be much minor. A lot of this energy is dissipated. So when we are having a flat wall, we are having a strong resistance. When we are having a circular curved, we are having a much less 0.6. When we are going through elliptical, and actually the ideal shape is a drop. So we are going through much less stresses. There are many different ways in this case to produce arches that will allow us to produce these shapes. So one of the cases is by using the whole length of a bamboo and interconnecting the tips and bending. There are many different ways to produce these bamboo arches, as I say. So these are some of the tests that I was conducting along with the group Caña Viva. I am the vice president, and we were making these tests on this local bamboo in Spain in the University of Barcelona. And we were unable to break it. Actually, after 500 kilonewton, the bamboo arch slipped from the machine. So you can see the type of deformation we are talking about before breaking. In the lab, they couldn't believe this. There is not any other material that can take this deformation before breaking. As I say, one thing which is very important, and this is when we are talking about this understanding bamboo and understanding construction, is that we cannot think about bamboo like how much resistance one bamboo can take. It all depends on the construction technique that we use. It's totally different when we are making arches, when we are making columns and beams. It will be the type of joinery. So actually, it's very difficult to think about testing the material, but we need to test samples and we need to develop tests to make higher one-to-one scale tests. So I'm gonna go very quickly now to have the time to show you more of these tests. Again, this is a very homemade test that we did in Barcelona based on, as you can say, just with some dynamometers. And we use also biometric to check the deformations of the different points. So I'm gonna go quickly just to show you a picture of what are shell bamboo structures. And all of these are things which I constructed with different people. In Spain, we used a lot of this, but then also here is in Meghalaya and in Nagaland. This construction specifically doesn't have absolutely any
Introducing
method.
Tidy and Tidy Pro, revolutionary AI-powered tools.
Sorry, I think
Service
there was.
providers using Tidy Pro benefit from an exclusive catchment area.
Excuse me,
Guaranteeing
I think there is something.
competition and stress, but certainly more productivity and higher returns on marketing spend.
Sorry, I think there is some background noise from somebody. No? Okay, maybe it was me, hopefully not. Excuse me. Yes, we were in Nagaland, and in this construction specifically, even, excuse me, even all the joinery was done through bamboo pegs and tying, different tying techniques. Of course, a very remarkable person, I cannot deny, is Bothron Ya. For me, probably he's the most remarkable architect right now, along with George Stamp, on doing very strong resistant bamboo structures. And this is a last ongoing project, which hope we will be able to finalize. This is again in the north of India, and this is a school in Bihar. So again, this is using local bamboos. As you can see, we are prefabricating the trusses on the ground, and then we are lifting up. There are several principles to construct with bamboo. One of them, I take the opportunity to show you here, is we always need to have knots on the extremes of the bamboos. The knot will prevent the bamboo from splitting, from opening. So one of the very important parts when we go to bamboo construction, apart from the design principles we talked before, we also need to be very careful on the bamboo selection and which bamboo will be for column, which bamboo will be for beams, depending on the different measures. So we always need to ensure that, as you can see in the picture, all these bamboos have knots before the bases, and these bamboos have knots right after the joinery. Then, yes, as you can see, this is some of these interconnecting members. And then, well, as I was saying, this is an ongoing project in Bihar. So now I have my last 15 minutes to talk about the specific experience on Mauritius. So when I came to Mauritius, I was very shocked by the circumstance of having to calculate for 300 kilometers per hour. Of course, when talking to the people, everybody shared with me the concern about the resistance to cyclones, and especially after the 1960s and the Carolina, how was the change of the scenario into adopting concrete as the main material. No? So basically, I started, and also COVID time was there. So I took the opportunity to isolate myself a little from other practices in other places, and I managed to develop a certain kind of joinery that could take this load. So I actually made an industrial design registration, but instead of hiding it, what I want is to share it with you all, and I invite all of you to please copy it and please come to me, ask me for questions. I am a completely open source person in this moment, and the only thing is that I am very concerned that the people, when they adopt a solution which is use copy, they copy properly. No, so yes, just this small note. So basically, through, and at the same time of developing this joinery, I developed this bamboo swing, which can take a very big load. And maybe some of you have seen this bamboo swing in some festivals or in IFM. And basically, well, this is also an example to tell you that when we are thinking about developing a product and innovation, maybe we are thinking, oh, wow, huge investment, huge means. I'm gonna confess you, I do not have these funds. As you can see, I didn't even have a proper track. So this was my little car that was used as a track, and we went through many adventures. So actually with quite limited means, you can start doing very good research. So actually, sorry, I want to share with you, sorry, I did the incorrect order. I want to share with you what is this detail and what is the research I have done on it and some applications. So basically, I was mentioning you that we have 3 species in Mauritius mainly, and one of them is what you call in Mauritius the bamboo duchine, which is this various, this kind of 3-4 diameter bamboo, and we can find it mainly on the higher plains of Mauritius. Well, I was very surprised by the capacities of this bamboo. This bamboo can grow up to 5 to 6 meters. So it can allow us to make arches that can take a span of around 6 meters, as I'm going to show you. So basically, the joinery consists on a cylinder of wood, which is perforated inside, okay, around which we are placing the bamboos. And then we will be screwing the bamboos into the wood, and then we will use some hose clamps to tie all the bamboos together against the wood. Then inside this perforation of the wood, we can put a threaded bar or solid metal, and like that, we will be able to fix it to a plate. I show you better. So yes, these are the screws, the hose clamp, and how will we put. And this is exactly the type of joinery that you can see in the swing I was showing to you. So basically, I will have a threaded bar that I place inside the wood. I place some nut, washer and nut, and then this threaded bar can be either, we can have a hook, either it can be welded to a metal plate and then screwed to a surface. It can adopt different solutions. This is an application of this joinery to a truss that I implemented, and this truss is a combination of small bamboo making an arch, and then this big straight bamboo. So yes, this is the joinery, and then sorry, because excuse me, because I made the order wrong for some reason. So this is the first test that I made at home. Actually, was my house in La Golette, and just basically with some scrap metal, thanks with the collaboration of Randy Bahadur, who has constructed hands with me, everything. We just designed this device, and we construct this swing. And as you can see, instead of testing the whole bundle, we just tested 2 bamboos out of it, okay? So basically, for the 300 km/h wind, taking that these trusses or arches would be not more than 3 meters of separation and 5 meters of span, then we need to have resist 2,000 2 tons of weight of stress. So basically, you will see in this homemade device, we were able to place more than 700 kgs, and I was not able to break the bamboo. Actually, what happened is that this threaded bar of the connection collapsed. And I show you now the other test. I still was not able to break it. Then we proceed with the first strong load-bearing construction in Mauritius, which I have done, which is this private residence villa in Saint Antoine. So yes, as you can see, I start by the end. So we have these are the structural members, and it's a combination of some it's stone walls and a bamboo roof. In this case, the ceiling is with rabanal. And you can see the straight bamboo and the arches. You can see the joinery we are talking about and how it is attached through a metal plate to the crown beam on top of the wall. This is a span of 5.5 meters. In this case, due to some time constraints, and also for the technique of the metal roof and other things, we had to go for the metal, rafters instead of bamboo. But bamboo rafters would be absolutely not a problem. And this is the ongoing construction. And then this is how it all happened in my little workshop in La Golette. And now, just to finalize, I wanted to share with you the latest test that I did, and also in the state where we are with this. So basically, this is, as you can see, this is the same joinery we are talking about. Okay. And in this case, I made several tests, okay? So this is, as I say, it is not about the bamboo separately, but it's about how do we attach it, how do we place it, and the interaction of the different elements. It makes no sense to break a bamboo. You will never find just a bamboo standing there on a place. The bamboo will be acting in a certain context, no? And that's why I want to share with you in detail. So here you can see the screws, you can see the hose clamp, and then we basically had the wood, the threaded bar coming out, and here we attach a hook. So this is, and this was done in thanks to the collaboration of Well Labs and Sebastian and other people whom informally allow me and help me to produce this test. So basically it consists on, we attach this cargo belt to this concrete block. Here we have the sample, the dynamometer, and then again the cargo belt, wrench, and then another cargo belt attached here, okay? In this is what's there. So now I'll show you how we were, oops, sorry, I attached same video again. So this is basically the bamboo, sorry. Yes, I think we are fine. Oh, excuse me very much. Excuse me very much. And okay. So here we are seeing a first test done. And as you can see, what we are doing is basically pulling from both sides the bamboo. So what we are doing is we are doing a tensile test on the bamboo, okay, mainly. So, excuse me, I made And basically what has happened in this test is that we reached 1,200 kgs, which was not too much. And then the bamboos slide from the wood. The bamboos actually didn't break, but it was the screws that collapsed. This is how, as I was telling you, with very few means, we are developing I am able to develop these bamboos, these tests. And here I let myself speak. So basically, what happened is that by making these small changes on the length of the screw, on the position of the hose clamp, we were able to achieve not 2,300, but 2,500. And we couldn't continue because, as you can see on this picture, the metal plate was bending like this. So we were having a huge risk of the metal of collapsing. And actually the thread was extending. So we had to stop due to the security reasons. We need to go through another lab, but just basically to share with you that after all this journey, we were able to reach that. The bamboo was not breaking, not even a single crack. So we were able to fulfill the necessities for the cyclone conditions of 3,300 kilometers per hour. And my belief is that this joinery can take more than 3,000 and 4,000 kgs probably. So this is all I wanted to share with you, and share with you that how much I really love bamboo, and share with you this journey, and invite you to please join me and start researching on your own. Thank you very much. Bye-bye. Claire, you are in mute.
Sorry, I just had to move. Thank you very much. That was amazing. So can we have some questions? Anyone got some comments that we can chat about? Thomas? Yes.
Yes.
Hey, go ahead.
Thank you. Thank you for allowing a question. I would be interested, what about the availability of the raw material? Is there enough bamboo here to scale up bamboo construction in Mauritius? Thank you.
Well, actually, that is why I started with working with this small bamboo, because we have gillions of small bamboos in Mauritius. There is absolutely no need to plant. If, as I say, if chamarel to the plains, coming down to the eastern Rivière des Anguilles and this, for in terms of the quantity of material, talking about small bamboo, there's a whole industry that could start right away. Then when it comes to the, I believe it's bambusa bamboos or other more gigantic bamboos that we can find, they are very difficult to harvest because they are not really purposely planted, as far as I know. So that actually would require a plantation. But Mauritius has the best conditions for bamboo to grow, actually. Thank you, Thomas. Nice to see you.
Okay. Louis. Louis, don't stand up.
Hi, Fatima.
Hi,
amazing
so happy to
experiment.
see you, Luis. Thank you.
Yeah. Are you in Mauritius at the moment?
Excuse me?
Are you in Mauritius?
Right now, no. Right now, I am in Chennai. I am spending more time in India in this. I'm kind of going back to India, but with a foot still on Mauritius. I'm going back on September, now at the end.
Okay, I just wanted to understand, when you did the bundle beam and you put the screws in through the bamboo into the timber pole in the middle,
Yes.
did you put the hose clamp covering the screw heads?
Covering.
Covering, yeah. So
the screws, no. So actually, you have this, imagine this is the screw, okay?
yeah.
And so the band is on one side. So what happened is in the first test, I put it on this side, okay?
Okay.
What happened is as I was pulling, okay, somehow this was getting far. So the hose clamp was useless on the first test. What happened is on the second test, I vary a little the length of the screws, as I say, a little deeper on the wood, but also a little more outside. And then I place the hose clamp on this side. So what happened is, what is really collapsing there, first of all, are the screws, because you have the wood inside attached to the foundation, and you have the bamboos attached to the wood. So when you have the stress of the wind pulling the bamboo will like to make like this, and the wood will like to get stuck there. Therefore, the screw in between will tend to do like this.
Yeah,
so
exactly.
Why you need to have the hose clamp on this side? And actually the hose clamp is fundamental, because then it's not one bamboo working independently, but
them all
it
together.
pulls them all together. And then also, when I was telling you at the beginning of flexion problems or torsion, no? By working with a bundle of bamboos instead of one, that's it. You can, bundle of bamboos can take any torsion, because the load is never getting to the internal structure. It's taken by the elements. You know this very well. Yeah.
Okay, well, let me know when you're back, because I have a little project I'm working on. I'd love to have a chat with you about it.
Great. Thank you.
Okay, is there anyone else that would like to share a comment or has a question? Fatima? So I think that wraps it up, guys. We're going to be coming back, committed to continuing this webinar, and hopefully about once a month, we present you with new topics for sustainable construction, and I hope you join us next time. Thanks so much, Fatima.
Thanks to all of you. Very nice to see you. Bye-bye.
Bye.
Thank you, everyone. Thank you, Fatima. Bye.
Thank you, Tony. Bye.
Bye-bye. Thank you. Bye.